Just mention if you have joined, mention your good evening in the chat box so that I'll come to know that people have joined. Okay, I'll start the session. So, where is it? Next is supernode analysis. So, it is almost similar to your super mesh. In super mesh, there will be a current source in between two meshes, isn't it? Similarly, here in supernode, there will be a voltage source between two nodes. So if you see a voltage source between two nodes, then instead of solving the given circuit to determine the unknown parameters by if you are applying nodal analysis, instead of going for nodal analysis, you must go for super node analysis. Okay, so this super node analysis is nothing but it's still a nodal analysis. Okay, so only the difference is that there will be a voltage source which exists between two nodes. So for that, what we have to do, we have to modify the circuits. If we are modifying the given circuit in order to implement nodal analysis, so that modified circuit you can call it as super node analysis circuit. Okay, so see here in this diagram you can see in between node 2 and node 3 there is a voltage source. So if there is a voltage source between two nodes, then you have to modify the circuit to determine the unknown parameters. So there is a procedure. I'm not going to discuss the procedure. Let us solve some numerical problems to understand the concept. So here they have asked us to determine the branch currents. Branch currents are already mentioned, some I1, some I2 and I3. So three branch currents are already mentioned. They have asked us to use nodal analysis. So if we observe, there are two current sources. So if current sources are there, so it's very easy to apply nodal analysis to determine the unknown parameters in the given circuit. But if we observe, there are two nodes that have been given here, node N1 and node N2. Okay, in between nodes N1 and N2, there is a voltage source. If, as I have already told you earlier, that if there is a voltage source between two nodes, then we have to apply super node analysis. Okay, so how to apply super node analysis, let us see. So here let us assume node voltages V1 and node voltage V2. Okay, so at node 1 voltage is V1, node voltage is V1, at node 2 node voltage is V2 and reference voltage is 0 volts. Reference voltage is 0 volts. Okay, so now if you want to apply supernode analysis here, what you have to do is initially you have to short circuit the voltage source which is there in between these two nodes, as well as if there is any series element with along with that voltage source, you remove that resistance also. Okay, so I have short circuited the voltage source. Okay, so if, as I have already told you, that if in between two nodes, if no element is there, you can consider those two nodes as one node. Okay, so N1 and N2 becomes what? One node. They will become one node. Why they are becoming one node? Why? Because here you have short circuited the voltage source which is in between node 1 and node 2. So if you remember, for super mesh analysis we have open circuited the current source. In super node analysis we will short circuit the voltage source between two nodes. Okay, so this N1 and N2 you can call it as super node. They are not two nodes now, they are single node. Okay, so you can replace these two nodes N1 and N2 by a single node. That single node is known as super node. Okay, so now this is our modified circuit. Now let us let me copy this in the next slide. Okay, now let us apply nodal analysis here. Nodal analysis at the super node. Okay, at the super node, let us apply nodal analysis. So see here, there is a current source 3 amperes coming towards this node. From this node, current is leaving, 2 amperes current is leaving, 3 amperes current is entering. Okay, and 2 ampere current is leaving. Okay, so what about I1 current and I3 current? Okay, they are also leaving the node. They are also leaving the node. So here, if we observe carefully, okay, if you observe carefully, I1, I3 and 2 amperes, they are leaving currents, and 3 amperes is upward, arrow mark is upward. Just observe the arrow marks here. This is upward, these 3 are downward. So 3 is entering current, 3 amperes is entering current, I1, I3 and 2 amperes are leaving currents. So apply nodal analysis, Kirchhoff's current law at super node. What is it? What do you get? 3 is equal to I1 plus I3 plus 2. Okay. So what is I1? What is I1? What is I1? I have already told you. Assume node voltages V1 and V2. So I1 is V1 minus 0. What is this? 0. V1 minus 0. I will take this laser. Okay. V1 minus 0 divided by 2. I1 is V1 minus 0 divided by 2. I didn't write 0 here. Similarly, what about I3? I3 is V2 minus 0 divided by 1. Okay. So replace I1 and I3 with node voltages. So in terms of write it down in terms of node voltage and their respective resistances. So 3 is equal to V1 by 2 plus V2 by 1 plus 2. Just simplify it. You will get equation number 1. What is it? V1 plus 2V2 is equal to 2. Okay. So this is our equation 1. V1 plus, where is my pen? V1 plus 2V2 is equal to 2. You will get, consider it as your equation 1. Okay. Now, let's go back to the actual circuit. This was our actual circuit. Now, before short circuiting this voltage source, okay, before short circuiting this voltage source, okay, so what is this voltage? V1. Here voltage is V2, node voltages, V1 and V2. So V1, the differential, we know for if current has to flow from one node to another node, okay, so there should be potential difference between those two nodes. Okay, if current has to flow from one node to another node, we just observe the I2 current here. I2 current is from V1 to V2. So always current will flow from higher potential terminal to lower potential terminal. So V1 minus V2, difference of these two voltages is the voltage drop across that element. What is the voltage drop? There is a voltage source value. What is it? 2. So V1 minus V2 is equal to 2. So just rearrange this. You will get equation number 2. So V1 equal to 2 plus V2. Now substitute 2 in 1. In your previous slide, 1, equation 1. In this equation, substitute 2 in 1. and simplify, you will get V2 value. I have got V2 voltage as 0 volts. Okay, so V2 voltage is 0 volts. That's what you have got. Okay, now substitute this V2 in your equation number 2. V2, that is your equation number 3 in 2. So if you substitute equation 3 in 2, you will get V1 is equal to 2 plus 0, and just simplify it, you will get V1 equal to 2 volts. Okay, now we have to find the branch currents. So by I1 is what? V1 by 2. V1 minus 0 by 2. V1 by 2 is 2 by 2 equal to 1 ampere. I3 is V2 minus 0 by 1. So V2 by 1, V2 is 0. So 0 by 1 is 0 amperes. Now substitute this, I1 value in your equation 1. I1 value, if you substitute in equation 1, you will get equation I2 value. I2 is 2 amperes. I forgot to write amperes here. Okay, so I2 is 2 amperes. So that's it. You have got I1 value, I2 value, and I3 value. So I1 is 1 ampere, I1 is 1 ampere, I2 is 2 amperes, I3 is 0 amperes. Okay, so let us solve one more numerical problem within 5 minutes. I will try my best to conclude this session. So we have to determine branch currents. Branch currents are already mentioned here. So I1 current, I1 branch, I2 branch, I5, I3, and I4. Total 5 currents we have to determine branch currents by nodal analysis. Where is it? Yeah, by nodal analysis. So you just see here, there is a voltage source. There are 3 meshes here. Nodal means we have to consider node voltages, isn't it? So if you observe carefully here, there is a voltage source between this node and this node. So if a voltage source is there between 2 nodes, you have to go for super node analysis. Okay, so if there is a voltage source between 2 nodes, you have to go for super node analysis. So here you don't have any other option. You can simply go for nodal analysis. You have to go for super node analysis. Why? Because voltage source is between this node and this node. Okay, so let us solve this numerical problem. So first of all, let us assume the node voltages. So here N1 is the node 1. So I will assume here it has node voltage at node 1 is V1. Node voltage at V2 is N2 is V2. Node voltage at N3 is V3. Okay, node voltage at N3 is V3. Node voltage at node N1 is V1. So this is our reference node. Voltage at reference node is always 0. Now if you observe here, this voltage source is directly connected to this node. Okay, if any voltage source is directly connected to a particular node, and if the other terminal of the voltage source is connected to the reference node, then that node voltage is nothing but the source voltage value. What is the source voltage? 10 volts. So V3 is equal to how much? 10 volts. So no need to calculate V3 value. So in order to determine branch currents, we have to calculate V1 and V2, but no need to calculate V3. Why? Because source is directly connected to the node here. Okay, and another node is reference node, but of course here also source is directly connected to the node, but other node is not the reference node, isn't it? So remember here, this N1 and N2 in between N1 and N2 voltage source is there, 5 volts voltage source is there, but N1 and N2 are not the reference nodes. Okay, so what is V3 value? Node 3 voltage is nothing but source voltage, that is 10 volts. Now let us solve this numerical problem. So what I have initially assumed is, I have short circuited the voltage source. So N1 and N2 are no longer 2 nodes, they are single node now. Therefore you can call this single node as super node. Okay, now let me copy this circuit, and let us apply Kirchhoff's current law at each node. Doing this. So now let us determine the branch currents. If you see branch current equations, I have simply written branch current equations first of all before applying Kirchhoff's current law here. So what is my I1 current? What is I1 current? I1 is V3 minus V1 divided by what? Divided by 2. So what is V3 value? 10. 10 minus V1 by 2. Okay. What about I2 current? I2 is traveling from V1 to reference node. So V1 minus 0 by 8. I2 is V1 minus 0 by 8. Similarly, what about I3 current? I3, I will erase all ints. So I3 is, this current is traveling from this node to this node. Means from V3 to V2. So what V3 is 10. So 10 minus V2, I3 is 10 minus V2 divided by 4. Okay. Next, what is left over? I4 current. I4 is what? This is V2. V2 minus 0 divided by 6. V2 minus 0 divided by 6. These are our branch currents. Simply I have written the equations before applying Kirchhoff's current law. Now, let us consider this super node. Let us apply KCL or nodal analysis at this super node. So at this super node, if you observe carefully, at this super node, I3 current is entering, I1 current is also entering, I2 is leaving and I4 is leaving. Okay. So two currents are entering and two currents are leaving. So algebraic sum of entering currents at a node must be equal to algebraic sum of leaving currents. So I1 and I3 are entering. So I1 plus I3, I2, I4 are leaving. So I2 plus I4. So I1 plus I3 equal to I2 plus I4. So what is I1? What is I3? Already I wrote the branch equations, branch current equations. So you just copy it. I2 and I4. You just write those equations here and simplify this. Okay, simplify these terms and you at last you will get 0.625 V1 plus 0.4167 V2 is equal to 7.5. Okay, consider it as equation 1. Okay, consider it as equation 1. Similarly, if you go back before short circuiting, what was our circuit? This was our circuit. Okay, so before short circuiting, what did I say? This was V1, this is V2. So difference V1 minus V2 is what? 5. I think I already told you at the beginning. I didn't tell at the beginning, it seems. Acha. It's okay. So for the current to flow, I5 current, this is I5. Okay. For the current to flow, there should be potential difference between two nodes. So V1 minus V2, current direction is from V1 to V2. So V1 minus V2 must be equal to the source voltage value. So V1 minus V2 is equal to 5. Consider it as equation 2. So simplify equation 1 and 2, you will get V1 value and V2 value. Okay. If you have doubts, you can mention in the chat box. I will clarify your doubts later on. If you can later on, you can mention in the chat box. So I1 from equation 1 and 2, you will get V1 and V2. Simply you can substitute this. If you have a scientific calculator, in that you just substitute the coefficients of these terms, go to equation mode and substitute the coefficients. You will get directly V1 and V2. No need to solve manually. Even if you want to solve manually, you can do it. Okay, so I have got V1 and V2, but in the question they have asked us to determine the branch currents. Already branch currents equations I wrote. I1 equation, I2, I3 and I4. So I1 was 10 minus V1 by 2. So what is V1? V1 is 9.2. So 10 minus 9.2, 10 minus 9.2 divided by 2, you will get 0.4 amperes. I2 is equal to V1. What is V1? 9.2. 9.2 minus 0 by 8. V2 is how much? V2 was 4.2. So I3 is I3 is 10 minus 4.2 by 4. You will get 1.45 amperes. And I4 is 4.2 minus 0 by 6, you will get 0.7 amperes. Okay, so these are all the branch currents in the given circuit. So that's it. I will just create the Google form and you can fill the Google form. Fill the Google form and leave. You can fill the Google form and you can leave the session. just conclude. I am ending this session.